Okay, so I just wanted to use Stackdriver monitoring and go over my thinking about how to use the metrics explorer here to properly set the values for CPU requests and memory requests. So first of all, we go to metrics monitor or metrics explorer rather, and then we look at the metric for Kubernetes container CPU request utilization. Now, if you go over to the docs for monitoring and look at Kubernetes metrics, and you can see that the CPU request utilization, which is the metric that we're looking at, the definition for that is a fraction of the requested CPU that is currently in use on the instance. It also says that the value can be greater than 1 because sometimes if there's availability, the kernel lets the process use more than it's requested. So by what this means is, by what fraction means, it's, if you have 5 cores, then that of request, and it's using all 5 cores, the value is going to be 1. If you're using 2.5 cores, then the value is going to be half. So it's just a percentage, in a way, of what the request is. So going back to this, we selected that CPU request utilization metric. We're going to group by container name because we have multiple pods, right? And so what group by means, it takes all of the CPU request utilizations across all the pods and turns it into a single time series. And then the aggregator, we're going to set to mean. So it's going to take the mean of all of the CPU request utilization across all of the pods that are of the same container name. And then we set a alignment period of 1 day. So what that means is it's taking, if you have 5 different pods, for example, accounting API, it takes the mean of all 5 pods across 1 day. Okay. Now, you look at this particular chart, we're looking at a 1 week view. And then we set an aligner, which is kind of confusing, but it's different than the aggregator. We're going to set the aligner to max. So what that means is we're going to get these little very distinct lines per day because what this means is we're taking the maximum, and if you read the docs, it says the aligner describes how to bring the data points in each individual time series into equal periods of time within each interval. The data points are aggregated into a single point. So once we take the average of all 5 pods, for example, I don't know how many pods there are, but we're just going to call it 5 for accounting API. Once we take the mean or the average of all 5 pods in a day, we're going to take the maximum during that day and represent it here, right? Now, if we didn't have an aligner, and we had the, it'll actually be a lot smaller value. Let me see if I can turn this off. No, I can't have an aligner. I guess I can align it over mean as well, but you can see the value is the 0.3. Because then what that means is it's the average across the entire day. Now, if our workload is idle all day, super busy for 5 minutes, and idle again, we might, get something like this, or we might get a very small value, like a 0.03. But that doesn't really help us set the requests properly because when it's working super hard, we want to make sure there's enough CPU for it to work. So this is why I go and choose max here. So that means that this is the busiest during the entire day that the accounting API gets, right? And so what this means is that over the course of a day, these services, some of them sometimes get busier than others. Like this particular day, Zen API or Celery. You can see like it's sometimes busier, sometimes, but it's on a day basis. And I think if we kind of look at this over the course of the week, we can kind of say that like take the mean value across these days perhaps, and then choose what the CPU request should be. So let's see. So the mean value across the week is the secondary aligner takes the average across the week and shows us here. So across the week, the maximum CPU utilization for accounting API across all 7 days is 0.36. So and maybe we can see if that makes sense here. It's too many lines here to actually tell, but yeah, I hope that makes sense. So based on this value, it's almost 3 times over provisioned for accounting API. Agency automation API seems about right. It's using at max over the course of a day. Almost its entire allocation, but something like this is way over provisioned. This is close to 2x over provisioned. This is actually under provisioned, right? So like I don't know how many cores it was given, but it's using almost 4 times as much CPU as it was requested, and that's because the instance itself was idle, and so the Linux kernel allowed it to give more CPU. And this is, I think, a good way. These settings are a good way of setting the values of getting the values such that we can go back and set the CPU request utilization for these containers properly, these pods correctly.